Hello, welcome everybody to my channel AG Maths, the way of life. Yeah. So today I have selected a topic called inversion. It is a type of transformation, and we have learned many types of transformers earlier. Like what are the transformations we have learned is number one, transformations by way of reflection. We know reflection is one way of transformation. About x-axis or y-axis, when we say if this is my mirror and one point is here which is called 2 comma 3, this is x-axis, this is y-axis, and we want the transformation of this point P by reflection. So what will happen? It will just travel like this and cross it in the second quadrant to this point, equal distance from here. The same distance will be covered this side, and the vertical height will also be the same thing as it is here. So we get another point 2 3, or it is called 2 minus 2 comma 3, and the point name is P dash. This is how transformation in reflection takes place. If it is the mirror and you have to bring the point down, then it will come like this. Suppose it is P double dash. The coordinate of this point will become what? 2 is positive, but 3 became negative. So 2 comma minus 3. Again, through the origin, the transformation was something like this, diagonal. So it becomes as minus 2 and minus 3. So it is point number P 3 dash. This was what we learned in reflection. Okay, now let's go to some other type of transformation. Another transformation what we have learned is called your rotation about a point. Second is called the rotation. Rotation is also a transformation. So what happens? We can rotate about a point and get the other coordinate. That is the rotation. Then we have a translation. Translation, this we will not discuss because this is not to be discussed here. Translation is another point which is meaning the shifting of the quadrant in strokes. Translation is, suppose we have first quadrant here, second quadrant, third quadrant, and the fourth quadrant. If a point is here, we go to this, then we go to this, then we go to this. This is the translation. Translation of a point. Then we have dilation or rescaling. What is dilation and rescaling? Fourth type of transformation is called the dilation or rescaling. Means if you have a point in the field and you want to put it in the map, or from the map you want to put it in the field, it is either you escalate it or you reduce it. So that is what is called dilation and rescalation. Okay, so these type of transformations we have learned. Another which is very important going to be discussed today is called the inversion transformation. Now for inversion transformation, I'll start with something. If we have a line made out of two segments, A1, B1 and B1, C1. Two line segments are there, A1, B1 and B1, C1. From here to here and here to here. So we can say that A1, C1 is nothing but A1, B1 plus B1, C1. This is how we say the sum of the whole line is made out of two small parts, A1 B1, B1 C1. So this is the very easy thing. Exactly what is this we are talking about? Coulomb's theorem speaks about. Now inversion we will use to explain Coulomb's theorem, and we have discussed Coulomb's theorem in our previous class. Okay, now we will talk about the actual inversion. If you take a picture of an elephant, suppose you have taken a picture of the elephant and you allow it to get transformation in the reflection, rotation, or dilation, or any descalation or anything, the shape of the elephant will not change. The shape of elephant will remain as elephant. But imagine the same elephant I am using for inversion. Then what will happen? The shape and size of the elephant will entirely change, and you will be surprised to note that it may look like a alien element from the moon, or maybe from some other planet which we have never come across. So let us see how it works. In our inversion, it will be completely different in shape and size, as I have told you. The circular picture may take the form of a linear one, and the linear one will take the shape of a circular one. So we will draw a circle anywhere in the plane. Here I am drawing a circle. So I have drawn a circle here with this center. Circle is drawn with the center at O. O is the center. Now suppose one of the point X is outside anywhere of the circle. We have a point X here. This is a point outside the circle. Now what will happen if it strikes the circle? Where it will go? Let us work out the modality for this. So we'll first of all we join the center with the point X, right? O is joined with center X, and from X we draw a perpendicular onto the circle. So the tangent to the circle, not perpendicular, tangent to the circle. So if this is the tangent to the circle at the point T. This is the tangent to the circle. Now from the point T, we draw another line which is called the perpendicular from T onto the line segment OX. If I draw a perpendicular from this point like this, then the point which comes here is called X1. This is how the point from X, which was outside the circle, has moved to inside the circle. What we did, we joined center to X, then from X we have drawn a tangent to the circle, and from the tangent point of contact we dropped a perpendicular on the line OX, and the point where it reaches is the point which has moved in inversion. Inversion makes X to X1. That is how the point has moved. Now let us take another point Y somewhere here. I have taken a point Y here. Let us see how it works. We'll again join O to Y, and from Y we draw a tangent to the circle. This is the circle tangent. Suppose this is S. S was the point of contact of this tangent drawn from Y on this circle whose center was O. Now again from O, we will drop a perpendicular on the line segment OY. So how it looks like? This is the perpendicular. So now this point Y1 is the position of Y when it strikes the circle. So the point outside the circle is moving inside depending on how far it is. From the center it was like this. It has moved to this distance from the center now. Okay. Now this point was little less than the center. Now but he has moved little farther away from the center. See this point OY1, we find that OY1 is bigger than OX1. What does it mean? But practically OY was smaller than OX very clearly. I have taken OY as smaller and then OX, and what happened when it went inside the circle, the shape changed. Okay, what happens to the point which is already inside the circle? Suppose we have a point here, a Z point, which was already there in the circle. So we'll draw the algorithm in the reverse fashion. What I'll do, I'll connect O to Z and produce it. Now this is a reverse algorithm, so I'll draw with a different ink so that you understand what is happening. So I am joining this and producing it outside. O to Z is joined and it is produced outside. Now what will happen? From the point Z, I draw a perpendicular on the circle. I have drawn a perpendicular on the circle. Here. This is a perpendicular touching the circle at this point. Suppose this point we call it as P. Then the other thing what we are supposed to do is draw a tangent from P onto the line onto the circle. So what will happen? This is the tangent. So this point, which is the intersection, is called Z1. So what happened? Point inside went outside. The point outside went inside. The point outside went inside. This is what is inversion. So point lying on a straight line goes inside the circle. Point inside the circle comes out to a point on a line. Right. This is the inversion process. That is, if the point is outside, it goes inside, and if originally it is inside the circle, it goes outside. Suppose the point on the circle is lying on the circle, then what happens to it? If a point is lying on the circle, this was a point, say, Z, Z, A is a point which was lying on the circle. What will happen to this point? This point will not go anywhere. If I draw a perpendicular tangent here, and if I join this, where it will go? As per the algorithm, it will never go anywhere. It may be another line parallel to it, and it will never meet. So when it doesn't meet, that means there will be no movement of the point A. So we say that the point on the circle remains. The first point we say point outside the circle moves inside the circle. Inside the circle by the inversion process, and the point which was inside will move outside the circle. When we are following the transformation of inversion, right? Inversion transformation, and the point on the circle doesn't move anywhere. It is fixed there. The point on the circle doesn't move and remains fixed. Now one thing we have already missed. What is the one point we have missed? If the point is exactly on the center, what will happen to the point of center, point on the center of circle of circle originally, what happens to that? It will remain there. It will remain there. Why it remains there? Because from O, can I draw any line connecting the point? The point is disturbed in the O. So there's no question of drawing any line. There's no question of drawing a tangent from this to the circle. So ultimately what happens? It remains there itself. So this is what is happening to the points which are at the center on the circle, on the circumference, which are inside will go outside, which are outside will come inside. Fine. Now let us examine one more problem. You have seen the external distance of the point matters. Distance of the point, if it is bigger, inside it is smaller from the center, and if it is smaller from the center, it is bigger inside the circle. The distance moved will be bigger. Now I draw another circle and let us examine some other point. We will take a line and see how the points from inside the circle will come out. Let us draw a circle again. Suppose this is the circle. I need one help to draw the circle. This is a circle with this as the center, and we have already a line, and we want to see if the points are inside the circle, how they will come out onto this line. This line segment I have already taken. Earlier what I did, I had points outside the circle and we have put the points inside the circle, and we saw how it reached inside the circle. Now I am examining the points which are already inside the circle and how they will go out. Suppose this is a point here, X, and we want to see how this point will behave when I follow the algorithm in the reverse fashion. So what we did, we have to join it from the center and produce it to the line. This was the point here. The line I have joined, and now from the point X, I will, no, from this point, I will draw a tangent. Alright, from here I draw a perpendicular. I draw a perpendicular from here. It goes like this. And the tangent at this point, suppose this was the point X. Tangent at this point is meeting the here at x1. This is the reverse procedure. Now another point, suppose z is y is there on the line. This is the y point here on the line. I'll see how it moves inside the circle. I'll connect it to the center O, connecting this point to the center O. Then from y, I'll draw a tangent to the circle. This is the tangent. Suppose this was your T and this is your S. And from center, not center, from point S, I'll draw a perpendicular onto this line. So this is a perpendicular. Suppose this is the point Y. Now one point was here, one point has come here. Now if the point is here at Z, then how it goes? When you join this and from Z I draw a perpendicular to the circle like this is a perpendicular tangent K here, and from K I drop down a tangent. So this is the point Z, Z1. You write it clearly. Now you see X, Y, and Z. If you look at it, this is a curve which is going round inside in a convex manner. Though these points X, Y, and Z were lying on a straight line. So the straight line becomes a curve when it goes inside the circle, or the curve becomes a straight line. So very well you can understand when I say what will happen to your elephant when it is subjected to inversion transformation. The elephant will become a straight line instead of becoming a same shape or size elephant outside. So inversion process from line to circle and from circle to line. So that is what is the result we are facing. Now the summary is lines through center go to themselves and lines not through the center go to intersection through the center, and circular through the center go to lines not through the center. A circle which don't go through the center of the inversion goes to the another circle not generally through the center of inversion. Now with this knowledge of inversion, we will try to prove the Ptolemy's theorem once again, which I discussed, Ptolemy theorem vis-a-vis the Pythagoras theorem. We hope, I'm sure that you have liked the video of today's discussion, and please click on the like button and also subscribe to get further information of my upcoming interesting and new videos. Thank you very much for your valuable time. See you again.